Hi friends, in this video we are going to see about merge sort. It is also in one type of sorting. We are arranging the elements in ascending or descending order. Now we are going to see about ascending order example, and it comes under unit 2, and comes under the subject design analysis of algorithm. So it is an divide and conquer method. So divide and conquer is nothing but dividing the problem into several subproblems, and we are solving the problems, and we are recursively it will be some combined, and we will get an output. So this is what the divide and conquer design. So initially problem will be there, it will be divided into several subproblems until we will get the idea of equal size. So the subproblems are solved, and recursively we are getting the subproblems in combined and get the original solution. So here we consider the problem of n size. The subproblem is divided. The n size is divided by 2. So the first subproblem and second subproblem. Again again it will be divided until we will get an equivalent size. So until we get then equivalent sizes solve the problem, then we will merge. They solve the problem, then we will merge. They solve the problem, then we will merge. So finally we will get the final solution. So this is an example for a merge sort. So here we consider we have 8 elements. So 8 is divided by 2, then is 4. So 4 is equally divided, then again it is 2 is divided, again we are getting single elements. So now we are comparing 8 and 3. 3 is lesser, so we are giving 3 first and 8 next. The same fashion we are comparing next to 2 elements and doing the process. So the solution will be given, and first element and second size are solved, and it is compared, and it is solved with an algorithm. That algorithm we will see in upcoming video. So this is an simple example for merge sort. If suppose this is an even number, if suppose we are having odd digits. For example, instead of 8, we have 9 elements, or if we have 7 elements, again we have divided the particular problem into divided by 2. So we are supposed to have 3 elements in the front and 4 elements in the next subproblem. So again it will be divided. 2 elements will be in the one problem, and one single element will be in the another subproblem. In the same fashion it will goes on for odd numbers. So for merge sort we have two algorithms. One is for dividing the big problem into subproblems. Another one is sorting the problems and combining those problems. So first algorithm is merge sort. So we have n size of array. So it starts from 0 to n minus 1. It is unsorted array. So this is what input array. The output is we will get ascending order element as an output. So first we will compare whether the n size is greater than 1. If it is correct, then we will copy the first half of the element to bth array, and second half of the element to cth array. For example, 0 to n minus 1 is the size of the array. Here we have n by 2 minus 1, that is middle half of the element. So a to some elements. For example, here we have 8 elements. So it is divided into first 4 elements are stored in bth array, 8 to 9, 8, 3, 2, 9. This is an bth array, and 7, 1, 5, 4. This is an cth array. So that will be stored, first half will be stored in bth array, and second half will be stored in cth array. So this is what copied and division is done and copied. So now we will again pass the bth array to n merge sort algorithm, and cth array to the merge sort algorithm. Again this will be done until it will divide the element until one single element. So this is what the first is in separation. Next is divide. Now first we will divide, then we are going to solve the problems and combine. Here it is, we are giving input as bth array and cth array, and it is of size 0 to p minus 1, and cth array 0 to q minus 1. So output we will get from 0 to n minus 1 and elements, that is of p plus q, is also called as n. So combined of b and c, we will get an array. Here we have three variables, one is I, j, k, and it is so initially with 0th position. So now we are comparing whether I is less than p and j is less than q. If it is true, then b of ith value and c of jth value is compared. If it is lesser, kth value, the b of I value will be stored in kth element and it will increment the ith value. If not, cth value will be saved in kth element and it will be increase the value. Again, finally, the kth position will be increased. Now I will show the example here. See, consider that last before step 2, 3, 8, 9 and 4, 1, 4, 5, 7. So here it is bth array is 2, 3, 8, 9 and cth array is 1, 4, 5, 7. So first we are comparing 2 and 1. Where if it is lesser, first we will check whether 2 is less than 1. If it is 1 is lesser, we are bringing that one value to the front, that is kth element. Then we are moving the jth value, that is now it specifies 4 as an jth value. Now it will compare ith value is 2. So again it will compare 2 and 4. If it is lesser, which one will be the lesser? That will be moved to kth position, that is 2. So now 2 and 1 are stored in the last array. So now we are checking, now I am increasing the ith value. Now I is 3 and here 4 is j. So now we are comparing, 3 is the lesser, so 3 we are giving to kth value, and now I am moving to 8. So now 8 and 4 are compared. If 4 is lesser, so 4 is placed in kth array. So now I value is moved to, keep an 8 value itself. Then now 8 and 5 are compared. 5 is lesser, so we are moving here. And again 5 jth value is incremented. 7 and 8 are compared. 7 is lesser, so we are moving this position. So and after that we don't have any values, so remaining values in the left array is stored in 8 and 9, that is stored in the last position. So here initially the up to kth position was done. If p equal to I equal to p, then we are if it reaches the position, then we have to copy the cth remaining element array to the kth position, else we will copy the bth array to the 8th position. So this is how the merge sort will work out. We have both algorithms we have to work out. Thank you.